Hey friends and everyone, welcome back to Netcode-Hub channel. My name is Frederick and I'm happy to have you here today. In this video, we are going to look at how to create robust and resilient web API. As usual, if you haven't subscribed to this channel, please do not forget. And also click on that bell to receive an update as soon as I do upload new video. The bell is found in this video. I hope you've seen that. Good. Alright, I do also offer coaching sessions to people who want to improve in their .NET skills, talking about Blazor Web API Service, Mari, and etc. So if you're interested, check the video description. I have an email in there. You can write to me through it. Okay. When we say robust and a resilient web API, what actually is it? It is any API at all which is designed to be strong and reliable even when facing challenges. Let's break this down for you to get the better understanding, the basic one, okay? Let's first take the first keyword, robust. Robust web API must be stable, meaning it should handle different types of input and a request without crashing. It must be error resistant, meaning it can manage unexpected error and provide useful error messages. It should be consistent, meaning it should behave the same way under different conditions by ensuring predictable performances. Good. So with these three key features here, if any API is having these features, we can classify that API as robust. Alright, this is clear, isn't it? Good. Let's go to the resilient. Resilient web API, what should it do? It should be fault tolerant. So it should continue to work even if some part of the system fail. It should be recoverable, meaning it can quickly recover from issues like temporary server outages. And the last one, it should be adaptive. So this means that the API should adjust to changing conditions such as varying loads of traffic. So if an API is able to possess these features at all, then we can classify that API as resilient. So now we spoke about at least 6 features that an API needs to possess to become robust and resilient. And in this video, there are a lot of features. We're going to look at some of them. I have already made a video on how to implement retry, wait and retry forever. Okay, this endpoint. Now these are coming from an old version of a poly. That is a version 7, but it still works. Okay, so if you want to use that, yes, you can go ahead and use that. But I know there are different things. There's a new package that is a poly.core, and this package encapsulates some of the functions or the APIs in this poly, and I'm making it very simple and easy to use. I'll take you through that. Okay. Now there are 2 packages. Maybe if you know poly, and now there's a new package known as an extension of what poly, and that is a poly.core. So with these 2 packages, which one should you use? Which one do you need to choose when creating projects and want to implement some features such as circuit breaker, retry, raise limit, hedging, timeout, fallback, and etc. So I'll take you through for you to make a choice on which of these packages that you need to use. First of all, let me show you. Now let's try to install this package first, then I'll show you the 2 types that I'm talking about. So make sure you have your project created. Like you see, I have a project created, what is it created? So there's a solution created, and I have added 2 projects. That is the 2 web APIs. I named them API 1, API 2. So let's see. Now we're going to install this poly package to API 1. Let me show you something in here. Right click on dependencies and I go to manage NuGet packages. And now in there, make sure you type in poly, P-O-L-L-Y, poly. Type in that and check it out. The 2 types I'm talking about. So poly. Great. Do you have this? Now you can see we have this. What I want to emphasize on, not what you see in here. Not this one. I want to emphasize on poly.core. Do you have poly.core? And poly itself. Okay, so I'm not seeing the main poly. I'm seeing poly.testing. Let me make it. Actually, let me do it well. So poly. Okay. So you can see we have this poly. And now this point, the current version here is an 8.4. As you can see from here, I have this poly package installed. And now we have an extension. We also have poly.core. So this poly.core and this poly, actually, they have the same endpoint. But the question is, why do they have these two polys? Okay, so check this. Now this poly here, I think it was, that is the date published. That is the 2024 May 10th. That's an update of the 8.4 from the version 7. Now when you go to the poly.core, it was updated or published where May 10th, the same day. So why do you have two packages? And now actually when you look at this, it has the same thing. So exception handling, resilient, transient, fault policy, circuit breaker. Now when you check this one too, it has the same thing. Okay, so let me take few seconds or a minute and I'll take you through the reason why we have these two. And now, which one to choose based on your project that you're doing or you're continuing. So first of all, let's talk about this poly. That is the main poly. Now this poly here, it is the legacy package that exposes the API used in the version of the poly prior to version 8. Now you know this is version 8, this is the current version. Now in version 7, that is why I've made one video using wait and retry, retry async, wait and retry async, retry forever, wait and retry forever. So these are the endpoints in that version. The previous one, that's the version 7 and below. And now it has been updated. So this is the original one, or this is the original one. That is the old one, which has been updated, and that's what currently we have. So all the current endpoint that I'm going to talk about here, poly package also has this endpoint. Okay, it has this endpoint. So now let's go to the poly.core. Then if this has the current updates and it has the previous one, then why do we have to get this? Now this poly.core package contains the core abstraction and our built-in strategies. It is the foundation for resilient policies and provide the essential building block for handling transient fault in your application. So this contains only the code made for version 8. But with this, I think you can have access to the version 7 and below. I hope this is clear. Now, if you are creating an application, which one do you think is suitable? Or which one should you use? I hope that's the next question, isn't it? Good. But if I ask you which one will you go in for? Now, the point here is, if you have started with Poly already, then continue with that, because all the feature that it has in the Poly.core, Poly also has it. But if you are now creating a new web API, then, my friend, make sure you choose Poly.core. Okay, so that is it. So in this video, I'm going to install Poly.core also. I'm going to have the two packages. So I have Poly and I have Poly.core. Maybe I can remove the Poly in here because I want to emphasize on this Poly.core. So let's install this package to it, and boom, we have it installed. Okay. Alright, so in this video, by using this Poly.core, it gives us an access to circuit breaker, fallback, hedging, rate limiter, retry, and timeout. Okay, there are a lot, but I'm going to talk about these 6 or 7. 6. But as you know, in the overview of a resilient and a robust API, we made mention of if an API can be resilient and robust, it should handle issues, exceptions. We are going to talk about handling exceptions using iException handler or custom middleware. Handling exceptions or errors that may pop up in your application is very important because it improves the user experience. It is not all errors that you want to get it to the user directly as it is. Some errors you need to hide them and now customize that error and now display something to the user. And in this case, you can handle that using an iException handler or the custom middleware. So I'm going to take you through both and I'll choose the one that suits what you're going to do. Now, iException handler is typically used when you want to centralize place to handle exceptions within your application. It also allows you to customize the error response and now logs errors globally. So with the iException handler and also the custom middleware, both support custom error response, and now you can also log errors globally. The key difference here is with the iException handler, this method is invoked when an exception is thrown, and with the custom middleware, it provides more flexible and extensible way to handle exceptions. So you can create your own middleware class to handle errors and add custom logic. So maybe if you want to check whether the user is authenticated, you can actually do that in your custom middleware, but you cannot do that in the iException handler. So take note, the exception handler is raised anytime an exception is thrown. But with the custom middleware handler, this gets invoked as soon as the app starts. And in that, you can add a lot of custom logic to it. Okay, and I'm going to show you both so you can choose the one that suits what you're going to be doing. That's great, isn't it? Okay, so in the previous video, I created a solution, and within that solution, I added the two APIs, and now we are simulating that the second as an API 2 is an external service that is going to make a call from the API 1. So in our controller, we install a poly package that's going to give us the access to Retry and all the policies that you want to implement to create a resilient and robust API. So we're having a Retry async, which is going to attempt 3 times. And now when on retrying, we want to display this, the console, and now passing the number of count or retries that has gotten up to. Okay. And at the end, we are going to execute this method. This method calls just get list. That's an array of weather forecast from this API 2. And that's what we did in the last video. All right. So with this, the first way to handle error is by using the try catch block. That is the local error handling. So with this, you can customize your error handling. You can customize the message that you want to put it out there for the user. And you can do a whole lot with it. You can also log it to a database or any third-party log live. You can do that. So you can see that from this endpoint that we have in here, if I call this get weather forecast, and in case I have any issue, I want to log this as an exception. So you can see here, this is limited, or this is specific to this endpoint. Okay, so this is how to handle exceptions locally by using this try catch block. Now, when we run this, let's run this and check it out first. So I'm going to run this with this bad request, okay, which has this exception being handled. And now let's see, instead of display the exceptions on the screen for the user, let's see if you're going to display that, or it's going to display the custom message that we have passed on in here. So let's run this and check it out. So the endpoint is ready. Now let's click on weather forecast and click on try this out. So in here, I'm going to click on our console. Now this console, we're going to have this log down here, and here we're going to have, you see, we're having this retry 1, and now the actual or the original error here, it is no connection could be made because the target machine refused it. So this is the actual, or this is a real error that's supposed to be displayed. But here we are overriding this error and want to display a custom error to the user. And now when you check it up here, you can see we have sorry error occurred. So this is the first way to handle that. Now we can check it up. We can just comment this. Now comment this one as well. And now let's give it a try and see whether we're going to have the original error displayed on the screen. And it is not a good idea to do that because some errors may contain sensitive data to the user, and it's not advisable to display everything to the user. Display to the user what he actually needs, and now keep what he doesn't need. And in doing that, you can use a try catch block to handle this locally within an application. So that is it. Let's try this one and check it out. So now this is also ready. Now this method is without try catch block, and now we are expected to see the actual error displayed on the screen for the user. And take note, this is not the best idea, so do not do this. Do not do this. It is not a good idea to display everything to the user. Okay, so make sure you display what the user needs. And I can see from the controller we are having this, and we're going to have the same issue in down here. You can see no connection could be made because the target machine actively refused it. And this is not the best way to do it. So try catch block to handle exceptions locally, and now customize the format to be displayed. Great. Okay. Now aside from this, we have this is used in to handle exceptions locally. What of globally? Now let's say it is not all the method that you're going to be using try catch block, try catch block, try catch block, isn't it? So if you want to handle any extra exception or any extra code which was not surrounded with try catch block, that is where you use the global exception handler. Okay, and now this time around you're going to use the interface of exception handler. So in case there's no try catch block, then exception handler is going to take in place of it. But when we have try catch block, then our exception handler will be skipped, because it's going to be check, do you have any are we handling this exception locally first? If it is, then skip the global exception handling. But in case there is no local exception handler, then please check or use a global exception handler. Hope this is clear. Good. Now let's create that first. Then afterwards we create the custom middleware. So before you create that, we want to customize our display. Formatting is very important. So we want to format a way that you want to display the error message to the user. Now, aside from this, we want to handle any extra exception that is not being taken care of by using this try catch block. We want to have a status code of 500. That is the internal server error. So aside from the customized or the local exception handling, we want to handle any extra exception that's going to come out as what? An internal server error. So with handling the global exception, you need to specify only one status code. Okay? And here, let's see how to do that. But before we do that, I want us to create a class or a model we're going to be using to format this. Now, I'm going to put it down here anywhere. Maybe I can create a folder and I'll name it as exception. Well, I can do that. Okay? So from an API 1, I'm going to create a folder for this. And let me say this is exceptions. So within that, I'm going to create a class of it. And now the class is going to be error details. So it should be API1.exceptions. Okay, so I have the name here, and now there is a class. It has a status code, and it have the message that I want to display to the user. Now in that, you have this method that's going to convert this into a string for us. That's going to serialize this model into a string, because you cannot pass model here into the HTTP context. What you can do here is to pass in a string. And before we can convert model as a string, we need to serialize it. That is the reason why we have this two string method. Yes. I wanted to say two strings. No, it's two string. Yes, that's great. Okay, then we are going to serialize it. So this here is referring to the context, and that's what you're passing in here. Very simple one. Clear. Okay, so now that we have this model, what the next thing to do here is we're going to create our exception handler. And now this is going to be in the same folder. I'm going to create app exception handler. So this app exception handler, this is a namespace, should be API.exceptions. So that is a namespace. And now this is inheriting from this interface. Our exception handler is coming from this diagnostic, from this Microsoft.ASP.NET So that's where we need it. Okay. Now we don't need poly here. So we have this exception handler, and now in that it has a default interface that we need to implement. And now in that you see we are specifying the content type, then we are specifying the status code here. So we are making a static one as what? Internal server error. That's the 500 status code. We're going to specify one status code for this. And aside from handling or exceptions using the try catch block, any extra exception that will pop up here, please assign status code of 500. Tell the user that wow, this is internal server error. That is it. And do you want to display any custom message? Yes, we want. For the purpose of this video, I am displaying message as custom message internal server error from the custom middleware. And aside from that, this is not a custom middleware. From this exception handler. So I think I copied this from the middleware. That's the reason why I have this. But that's not what you want. So exception handler. Now aside from that, I am also appending a new line and now displaying the real exception. This is not the best way, but I'm displaying for the purpose of this. But in a production purpose, do not this. What we're going to do here is you can log this exception to your database or to any other third party or a container that you want to do it. Okay, you can do that. But do not display this on the screen to the user. It is dangerous. Okay, then we're going to convert it to two strings. We're going to convert this. We're going to serialize it into a string. Then return default, because this is going to be boolean, so we need to return default. Okay, and that is it. Very simple one. You see? Yes. So once I've done this, the next thing I'm going to do here is we go to the program.cs file, and now we need to register this and now use this in the middleware pipeline. Okay? How are you going to do it? Or how are you going to do it? So it's a very simple one. We have to register the service for this, and we need better services .add exception handler. You pass in this app exception handler. Aside from that, we need to use the middleware pipeline, so it can be called anytime there's an exception, can be raised up. So use this app.useExceptionHandler, and I use this to raise that class up. That is all. Okay, now let's first check. Now we go to our controller in here. We have try catch block. Now let's try this up and check it out. So let me uncomment this. And now from the first, at the beginning of this video, I said that when we have this exception being handled locally, global exception will not going to be executed. Although to be executed by sent to task, is going to be using this to display to the UI. But in case there's no local exception handling, that is where the global comes in. Hope this is clear. Good. Now let's see. So click on this. Now let's run this and now check it out. We have a global exception. We have the local exception. Now let's see which supersedes each. Let's see whether it's locally or it is globally. Wow. Let's wait and wait for this to get run, and we can click on the button and then see whether we're going to have this error code or we're going to have custom message. Okay. Now let's go. Bingo. So we're making 3 retries. There's the first one, second one. You're going to have the last retry. Then you're going to pop up our issues or exception. Now let's see. So we have in here, we don't have any custom message in here. That's great. Now when you check here, you can see we have error code. Error code. And now this is having a response of 400. Error code. So you can see that although we have the global exception handling in place, it is still using the local one. Yes, of course, because anytime there's local one, global is going to be skipped. Take note of this and keep it. Good. Now, aside from that, we go to the controller, same place again. Now let's comment this. Have we done that? Now this open is opaque, empty. Okay. So exception that get in here is going to be popped up. Yes. And now let's see if we're going to handle that globally. Let's see. Now let's check it out. So I'm going to click on this, try this out, and now let's see. So from our console, we must have a first, second, third retry. Then we must have a pop-up of our exception. Let's see whether it pops out to the console or to the UI. So that's the third retry, and the next retry here, we must have an issue. Yes, so we have this an error from this section. And I want to check it out. You see we have an unhandled exception has occurred while executing this request. Okay, so there is an exception. No connection could be made because the target machine actively refused it. So there's an exception. Now let's check it up here and see. So you can see from the user we have the status code of 500. That's the internal server error, and that is what we have in here. Now there is a message. So you can see we have custom message and so internal server error from the exception handler. And now there is the actual message that you want to, or you have to log to database or to any place at all. And it is not advisable to display this to the user. But for the purpose of this, I got to show you this. So you can see we have the same thing repeated in here. But this is what we want to display to the user. So you can see this is a nice way of customizing or formatting your exception to the user without displaying the actual exception. Because it could lead to some hack. It could lead to some threat posed onto your system, and it's not good to do that. Good. Now that you are clear with the exception handler, how do you implement the custom middleware pipeline? You know, custom middleware pipeline provides a flexible way to extend the exception. So you can see with the exception handler, all that you need to do here is log it or to get raised anytime an exception is being thrown. But with the middleware pipeline, it is not only an exception. You can even check the context of the HTTP context. You can check whether it is authenticated. You can check a whole lot, okay, in that. And it is actually broad one than this. Let's see how to also handle an exception using this middleware pipeline. Okay, so I'm going to close this one. Let's close this too. Okay. Now with the middleware pipeline, the same approach happens in here. If I use try catch block, exception are going to be handled locally. If I undo this like what I've done here, exception are going to be handled globally. So you want to focus on the global one using this middleware pipeline. Okay. So we're going to also create the same class in here from this exception handler. And now this exception handler, I'm creating a class known as a custom exception handler. It's going to use the same model that we created in here. So we are not creating a different model. And now this is a partial class which takes in a request delegate as a next, because it's going to execute the next one when it steps into this. After stepping out, it has to execute the next context. Okay, so we have this to log as an iLogger, and now here we are going to log it. Now when you check here, we have this HTTP context in here, and now we are going to execute this. So after executing the, you see we are using this try catch block. So in case you have any issue in here, it's got to be catch up in here. So that's an exception. Now when you got the exception in here, we can log this exception to the database or log it to the file or anything else. So you can see we are logging it to the UI, or not the UI, the console. And now we call this method as handle exception. We pass in this as a parameter, the context, and now this exception that we have in here. Now if you refuse, or if you don't want to log the exception in here, you can decide to also log the same exception in here to the database. So you can see I have also all log exception to the database here. Now we specify the content type, we specify the status code, and now in here we having this detailed. So this must be the exceptions. And then here you can see we have the same thing. So we are populating the same thing from here, and as we did, all that you need to do here is to change this custom middleware to exception handler. It's the same thing. And I'm going to return this. So you can see from here, you can actually perform some tasks as well, as you can see from this HTTP context. And now this class get called as the app start, or a method is being called, which needs a context of this HTTP context. But with the first one, the exception handler, it gets invoked when an exception is thrown. Okay. Now for us to understand that, let's see. I'm going to put a breakpoint in here. Okay. Now I'm going to put a breakpoint from this exception 2 in here. Let's see which get executed first. So let me put a breakpoint in here. Oh, it is not pointing. Yes, that's great. Okay. Now in order to do this, let's also register this. How do you register that? We need to do that in the program.cs file. So we're going to use app.use custom exception. So from your program.cs file, let's see. So put it down here. Okay. So we have this middleware so added. That's great. Now we're going to run this. We have a breakpoint point add to the to method, and now let's see which one gets executed. Now let's click on the weather forecast, and if I click on try this out and I execute, let's see the point is hit, and I could see this custom middleware pipeline has been hit. So anytime there's an instance of this context available, this method get hit, because here is the middleware that we will know. And now we have this next, so it has to execute this context first. Now let's see, so click on continue. And now when we have an issue in here, when we have an error, that is where the exception handler gets invoked. So let's see, it is executing. And now let's see this. From the exception, you can see this is not hit. But let's wait and now check it out when we have the error in here. Yes, and you can see that as soon as the exception is thrown, that is where we have this. Now when you check this, you can see we have the exception thrown in here, and as soon as it gets thrown, that is where this method gets invoked. So now you now see the difference, right? So the middleware get executed when the app or when HTTP context is being initialized and start to work, while this method and app exception or this exception handler get executed when exception is being thrown. Okay. Now let's click on continue, and I could see we are having the same response from the middleware. So you can see that we are arriving at the same thing from the same result using the custom middleware and also the exception handler. So you make sure you choose the one that suits what you want to do and now integrate that. Alright, now let's see. So now that we have these two packages installed, what I'm going to do here is I'll go to the packages in here from the dependencies and our packages, and I have poly and our poly.core. Since I am emphasizing on poly.core for the new abstraction, I want to remove this poly which contains the old one. Maybe I'll have some time to go through the old one as well when I have time. But well, when you install these two packages, you can use the same thing together. It's the same. Okay, so let me remove one and I maintain this poly.core. So you know, in the point, the current, that's the 8.0, 8.4. Now, instead of you to use, or when you want to use the retry, in the old one, version 7, you have endpoints such as wait and retry, retry forever, retry async, retry, wait and retry async, a lot. Okay. Now all these, the abstraction here, it has been, the Polypack team has made it one, so we can now add poly in the version 8. Now, in order to add version 8, you can first put it in the program.ts, so I can register it as a service, so you can be using that. Or you can also use it based on the file. So you create an instance and I start using that. Now, in order to use that, you have to first create an options. You can decide to specify these options in the pipeline, or you can create an options in that and now call this option in the pipeline. Well, talking is too much, isn't it? Are you confused? Don't be, because it's very simple. Now let's go through and now let's see. So first of all, let's have a look on retry. So what is the purpose of retry policy? The purpose here is a retry fail operation and for a specific number of time before ultimately failing. So you know, when a user executes a request, and if the server which is going to respond to the request fails, we don't want to return the response once the server fails. We want to retry again, maybe based on the specific number that you're going to specify. You want 3, 4, 5, 6. Then within our request, if it still fails, then we can tell the server that hello. We can tell the client that hello, yeah, the server failed. Or you can handle that exception using the global exception or the interface, exception interface to handle that, and I display a certain message to the user. Okay, so that's the purpose of having this retry policy in the poly. Let's see how to implement that. So as I said earlier on, we're going to make our API to us an external service. Although we have it over here, but think of something in the air. Okay, something that you're going to have access to. It is somewhere else that we're going to have access to, although it is close to us. Does this make sense? Yes. Okay. So let's say now in our API 1, you can see we have a default controller. And at this default controller, in the previous video, I made mention of, I did this, all this. I did this, all this. Yes. Yes. I did this, all this. I did all this. I'm going to clear all this. That is using the version 7. And here we're going to use a retry async and I'll retry and wait. Retry forever async. That is a version 7.0. And now I'm going to cover that anymore. And I want to cover the new one. So maybe I would have to get rid of this. Yes. Okay. So this is what we have. You see, I am injecting an HTTP client into a constructor, and now using this primary constructor, I mean, you're going to make this instance available from the scope. No, from the scope or to the scope. Yes, within this scope. So it can be used anywhere. That is a C# version 12 and introduction of what primary constructor. All right. Now, once we have this in here, let me remove this from the top here, because they are not of no use. Good. Now there is an endpoint 7001. There's an endpoint to the second API, and in here we have there's a method called what? Connect, which is returning an HTTP response message. Okay. So here we have get, and this is going to return an IEnumerable of weather forecast. So we're going to make a call to this endpoint in as a service sitting somewhere else, and now when we get a response, we're going to return it in here. But we're going to make this request server failed. We're not going to start the server, so that we're going to have no machine, or the machine refuses it because it is not actually live. Now, in that, we need to retry the server time based on the specific number that we're going to specify before we finally or ultimately what? Failed. Now, let's try that and see. So once we have the package installed, so first of all, let's create a retry strategy. I said earlier on that if you want to use any endpoint in here, or any strategy, you have to create the option. Aside from creating the option, then you can use this option in the pipeline. So there are two things: create an option or use the option in the pipeline, or you can specify the option when creating the pipeline. Okay, so it is two. I want to separate it so that maybe it will become clear to you than specifying it at once. Well, it's a choice, so choose a choice. It is my choice, choose yours. All right, so first of all, we're going to create this strategy, and I mean that, let me just uncomment this. So you can see that here we are creating a retry strategy, and this we need to use this poly.call. That's a retry. So when you have a look here, you see we are creating this strategy, and now we need retry strategy options, and this is coming from the poly.core package that we installed, and a section, a class known as what, the retry. Good, that's the namespace. And now in here we are specifying using poly delay backoff type as an exponential. So when increasing, do you want to make it as constant figure or do you want to make it as an exponential? Yes, so we're going to use the math.power. Yes, you're not doing math here. Let's continue. Okay, so this is going to add a random factor to the delay. That's the use jitter. And now maximum retry attempt. So these are the things that matter most. Maximum retry attempt. So here I want to retry 4 times, okay, before we delay, or we can, no, before we return to the user, or we can retry maybe 6 times, 5 times in here. Now delay for 4 seconds each. So if I make a first request and now it dies up, it couldn't connect, then I'll wait 4 seconds, I'll make another request. So I'm going to retry for every 4 seconds here before to check if the server is alive. Now on retrying, I want to display this to the console. Okay, so this can be, you can call any method at all, but here we are calling something to the console so we can read what is going on. I hope this sounds great. Good, after doing that, do you know what the next thing to do? We are going to create our resilient pipeline and now build it and now add our retry strategy. So the strategy that we have created in here, we need to create a pipeline, and now we add our, so let me comment this. Yes, so you can see from here that we add this retry. So resilient pipeline, this is a pipeline. Maybe I can make this as retry pipeline. Yeah, this retry pipeline, and now we add this strategy in here into the pipeline endpoint that we call in here, and now we're going to build that. So after I build that, this pipeline is now ready for execution. How do you execute? How do you execute? This is very simple. So in order to execute, we can just have something very simple like this. Let's see. Now I know that we have this connect API, and now this is going to return HTTP response, isn't it? So maybe we can, this is unused, so we're going to use it now. Now let me uncomment this. Okay, so we have copied this retry pipeline, and I'm going to replace it down here. Now within this, we are calling a response.await. Now this is going to call, so instead of this, we're going to replace it with this one because this is, we are using a method down here. Okay, so we call this is going to return what, HTTP response, and now we can check if it is success. Then we want to convert it into what, a list of this, visualize it, and now if it is not, we're going to throw an exception. Okay, so if it isn't, we're going to throw an exception, and now with this exception, you know, from this we are going to handle this. And now defaultly there's another endpoint that we did not configure, and that is should handle. Now should handle here, that's where you need to specify the exception that you want. Defaultly this is specified to any exception aside from cancellation or cancellation exception. So defaultly that is what has been configured on. That's the reason why I am not configuring this should handle. Okay, but we can still override it. In case we want to do that, we can override this exception, this should handle property in here. So in order to handle this, we have to specify with this as new predicate, and our predicate builder this, and now in here we are going to specify .handle. So which exception, and now you want to handle all exceptions. So maybe you can make it specific to this, but we want to handle all exceptions in here. Okay, so any exception at all that's going to be raised up when this method is being called up, that is where you're going to execute this. Okay, all right, so now that we have this, what else can we do? We can now go ahead and now run it. Now you can see if in case everything is all right, then here we are returning result. Now the result that we are returning in here, you can see we are using this lambda expression. So the endpoint, the end here is going to be result of this. Now when you have this result, that's going to be what? That's a list of weather forecast, and in there we want to return this weather forecast. Okay, so that is exactly what you want to do. Now let's try this. We make sure we have our console running up, and now let's check it out. So I believe you can now see the screen. So we have the Swagger open down here. This is on our left. Then we have this on our right. This is the console, and now we're going to click on this. You know, we haven't started there. We are starting only the API version 1. That's the API 1. API 2 is offline. So definitely when you try to make a request, it won't reach the server. Okay, so in this, you're going to try an exception. And in that, we are handling this exception, and we're also calling a retry again based on the exception that we have. Now see, click this, and now execute this. Now let's check it out. So you see it is sending a request to this 7001 endpoint to the controller this, and I couldn't. It failed. So you see I'm having a retry. So this is the first attempt. So attempt here after making a request. This is the first attempt. It is still not sending. It couldn't. Second one is still, you see, so waiting, attempting one. So we have 2 attempts. This is the 3rd attempt that is making, and we specified around, I think, 4 retries. So let's check it out. So this is 1, 2, 3. Maybe we have last one. Then we have the 4th type. And in case this fails, then we are going to return, okay, to the user. So we see that the user clicked on once, but since the server failed, we are retrying how many times? 4 times. Oh, okay, so it is no more 4 times, it's 5 times. That's correct one. Yes. I don't want to deceive you. It is 5 times. Okay. So now when it got to the 4th one, you see from 0 to 4, that is 5. When you go to the 4th one, you have an exception in here. And if I open this, let's see, you can see that we have this. No connection could be made because the target machine actually fits it. So this is the error that we are having from here. Okay, so this is an error that we are getting. Great. And now in this case, instead of us to display this to the screen, no connection could be made because the target machine refuses it. Instead of displaying this raw exception here, to make your API robust and resilient, you must have a way to handle what? Exceptions. That's the first one. So we are handling this exception, and that is what we did in here. So you can see from here, we are handling an exception from the application exception handler that we created or we went through that time. I made this a video, okay, so you can just have a look on that. And now within that, we are having this at the output. So check it out. You can see instead of displaying this, we have a custom message internal server error from the exception handler. So I decided to add the exception itself, so you can see that, yeah, that's an exception, that's a real exception. So instead of displaying this, we are displaying this custom message to the user. So the user might not know that it is the server is off. What maybe you can display here, maybe sorry, server temporarily down, or sorry, wait for some time and try again. A lot, okay? You can do that. We have a default status code of 500 as we specified in there. Good. So now we are done with the retry. Now let's go to the next endpoint or the next feature that we're going to talk about, and that will be timeout. So what is the purpose of implementing timeout in your API course or in your service course? The purpose here is to set time limit for an operation to complete and cancel it if it takes longer than what's expected. So here you can avoid waiting indefinitely for an operation that may hang or take too long. So in case it takes too long, then cancel that request and you go your way. Very simple one, okay? So in that too, let's see how to handle that as well. We go back to our same end controller in here, weather forecast, and now within this, I think I have to comment this. Or yes. So in timeout, we are going to be using cancellation token. So we have to pass the cancellation token to a method that's going to make a call to the API. And this is very important. And this cancellation token will make sure that it get the request cancelled when the time overlaps or it delays for too long. Okay. So here we cannot use this method. So we have to create another one. So I'm going to create this connect to API 2. And then that I'm going to specify, I'm going to pass in maybe cancellation token to this. So maybe I can do that like this. So here we are returning a list of weather forecasts. We can also return the same HTTP response. And now that's in the connect to API 2. And here I am specifying cancellation token to this. In that, I didn't want to delay this, so that's the reason I commented. And now we're making a call. We're passing the cancellation token. For now, that's the default one. Default one is none. And now if it is success, we want to return the list. In case it isn't, we want to return default. That's going to be empty. Okay. Or we can still implement this HTTP response. We want to be dynamic here so that you know that, yes, we have a lot of ways to implement this. Okay. I believe you like that. Yes, I know you will. Definitely. Okay, so now that we have in this, what's the next thing to do? I'm going to make another endpoint for this. And we're going to also make a same call. So let me grab this from here. Let me comment this. And I'm going to say this is, okay, so maybe let me give this a new name. And let's say this is retry. Now this is going to be timeout. That's timeout. So timeout. Now this is gonna be retry. Alright, that's fine. So from here we have to implement this ourselves. So let's create our timeout strategy. So I'm going to say that this is timeout strategy is equal to new timeout strategy options. And in that, I'm going to specify this. So the timeout here is what? From 1 second. So if it delays, maybe let's make it 2 seconds. Okay. If it delays for 2 seconds, then you want to set a timeout. And now when it's timing out, when it exceeds, we want to write some to the console. So existing time out after the total seconds, what? Total seconds in here. So time is out. You want to just display something like the time is out. So once we have this timeout, the next thing we're going to do here is we have to create our resilient pipeline and implement this timeout. You can see this is very simple, isn't it? Creating timeout is very, very simple. Now, with this, let's see how to work with that. So down here, let's create our pipeline, timeout strategy pipeline. So this is our pipeline. And now in that, we're going to get it from this. So we can grab this one. Maybe let's remove this. Since we're not having a separate class, then we pass in our timeout build up here, and now we build this. So once you build it, then this timeout becomes ready for us. So let me make it as timeout pipeline. Good. Now let's use this pipeline to execute our request. And in that, we're going to specify as a token in down here from this async. And now we're going to specify that token here. Since this method needs a token for cancellation, we have to pass it on down here. Return result, because this is returning a list of other forecasts. So we need not to check the state again. First we are checking the state from here, the first one, checking the state from this retry. By timeout, you are not checking the state. yeah, returning straight away because we checked the state already. So be dynamic. We don't want to be focused on one side. Okay. All right, now that's good. So let's see. Now let's run this and also check this out. Yeah, so our endpoint is also ready, and that's a timeout. Let's make sure console is visible for you to see what that we're going to have. Let me increase the size here. That's great. Now, if I click on this execute timeout, check up here, we're going to have two responses. One from the UI, which is inheriting from, or which is coming from the exception handler. So hit on the button. Yes. Now let's wait and see what will happen in here. Okay, yes. So we run to an error. First of all, let's check up and see what is an actual error that we are having. So if I go up again, up, yes. Check it out. This is a poly timeout. So this is an exception. Timeout rejected exception. So this is exception called as soon as the timeout that we specified executed. So the operation didn't complete within the allowed timeout of what? This is a timeout that is supposed to use to execute complete, but I couldn't. Within that, a task was cancelled. You see this? Good. Now, from this, we are not displaying this to the user. So we are displaying it from the custom exception. Whoa. Custom exception, internal server error from our exception handler. But we have the actual exception in here. The time did not complete in here. So once you have the time in here, you can now format it to suit the user's choice. What is that you want to display to the user? You can do that specifically with the exception interface. Alright, so our timeout is also working. Now you cannot make a request and the request won't last 5 seconds, 10 seconds, 15 seconds whilst you still sit. You still sit and stay. Okay, yeah, and wait for the request. So you sit up, when the time is up, the operation gets cancelled and now you can make another request. Okay, so let's say, so maybe if you want to also retry after the operation has been cancelled, then this is coming out exposing a cancellation, maybe exception, or that is a timeout exception. So you can make an retry to handle a specific exception, that is timeout exception. As soon as this exception gets erased, then it can also retry again. So it will back and forth. The retry will try. when it gets to the cancellation token, that's the timeout, it will cut it down in case it couldn't get the response based on the number specified. Then it can retry again and so forth. It depends on how you want to do yours, but there is a way, so you can manage it yourself. Okay. All right, so let's go to the next point, which is fallback. So what is fallback policy? Now, the purpose of fallback policy is to provide a fallback action if the primary action fails. So it ensures that the application can provide a default, at least default response, or handle errors gracefully when an operation fails. So let's say you want to return a list of maybe weather forecast, okay, from an endpoint or from a service. Now, when you make a request, it failed. You don't want to return the request or the failed message. You want to just return the default. Now, default is an instance of this list of weather forecast with no value. You want to return that to the user. And in this case, you have to use a fallback. So if you are planning that you want to return something when something happens or when an exception happens, then you can use a fallback. Now, let's see how to also implement the fallback. So I have to close this up. Let me close the console also. And I have to make another endpoint and I name it as fallback. So let me grab this from here. Let me minimize this. So I'm going to make this as fallback. And that is a fallback in here. And then the same thing applies to the name. So default, you know the return type of this method is returning a list of weather forecasts. So first, let's create our strategy. That's a fallback strategy option. So let's first see. We have our fallback strategy. And now here we're going to say that it's equal to new fallback strategy option. And now with this strategy option, we need to specify the return type that we want. So that's a list of weather forecasts. You know this is what you want to return, right? So list of weather forecast. Oh, see what I've done. Okay. So let me remove this. So list of weather forecast. And now in that, we need to specify the following options. So when you have a look in here, you can see we have should handle. So it should handle what? That is when we get a list of weather forecast. Now this is the predicate, and here we also specify the list of weather forecast. This is the return type, and that's what we have it down here. No, up here. There's an exception in case you have any exception. This it cancels all exceptions except cancellation exception. Okay. Then we want to handle this result. So if the result is null, then there's a fallback. Here we want to get a default weather forecast, and that's if we create an instance of this list. And now we want to return as an outcome.from result as value tags. We pass in the instance in here. Now when it falls, you want to write this to the console, and I return default. This is a very simple thing that you want to do. So anytime that there's an exception here, you want to return a list of this. Instead of displaying an error, no, we want to return a list of this. So the errors are going to be hidden. That sounds great, isn't it? Now let's see. So once you have this, it seems like we need to clear this. Yes. Okay. So now that we have this, we have the strategy. Let's go ahead and I use this strategy to make an execution. So we can have our pipeline instance created beautifully here. So maybe let me push this because this part. Okay, so we have a pipeline, and this is going to be fallback pipeline. And then here we could see we also specify the return type. And now in that we have our strategy copied. We can place it down here. We build that. Making a request from our fallback pipeline. Then we're going to make a request. Now this request, we don't need any token. Okay, so it is only the timeout. That's why we need cancellation token. But with this, we don't need that. So we can just return, get it straight ahead here, and I return data to as an OK type. Okay. So this is returning this return HTTP response. So we don't need that. So we have to return maybe a list of this. So well, we can pass in still cancellation token, which will still be okay because this is return a list. So maybe we can grab this. Let's make this, copy this token in here, and now pass the token in there. Very simple one. Now let's run this too and check it out. So on the go, we have it ready for back. Let's try this out, execute this. Now we're going to have an issue here because the server is down. But let's see, you can see fallback returned, right? So you can see there's a message, fallback returned. And now when you check it, instead of displaying this error, we have an instance of this. So instead of our errors, where are they? They are going, they are hidden, they are gone. We have the instance that we created. So you can pass on default data that you want. You can pass it on that, okay? And you can go ahead with this, okay? So maybe let's try one passing in the data as an instance of this. So once you get this from our fallback, you can create from here. We can say that this list default weather dot add. Now here adding new. So adding new weather forecast, and now with this date, you can specify date as datetime dot UTC now. UTC now dot date. Would that be okay for this? This date here, it is date only. So do you have dates only? So dot from dates, from days. Okay. And aside from that, we can have our summary. Maybe this is it windy? Yes, that is windy, right? Now the last one that you can have temperature here is, let's say 34. Great. Then we can now close it. So you can see that we are creating a new instance of this, and aside from that, we are adding it to this default list that we have created. Okay, so maybe we can set up to this new one. Well, this can work, or we can also use simplified one like this. This is also going to work. Pass it on in here, and now let's give it a try and check it out. So let's see the default fallback. Anytime that we have an issue, we want to get this as a fallback. Exactly. Okay, so that's a way to also handle the fallback. Now let's see the next one. And that will be circuit breaker. Circuit breaker. What actually is circuit breaker? The purpose of circuit breaker here is to break the circuit for a specific time after specified number of consecutive failures, stopping further attempt and protecting the system from overload. You know, like they know service here, it is down. Now all service are going to make requests to this. In this case, we want to break this service down. We want to open circuit. Okay, so this looks like a bulb in our room. You know, we have a switch. Now as soon as you shut it on, the circuit is closed because it is connected together. As soon as you off it, the circuit or the connection is broken. You have a space in there. The same thing applies to this. When the circuit is opened, it means there's no connection, so you cannot pass a request to the server or the service for a processing unless the circuit is closed. So in that you have circuit open, we have on reset, meaning when it is closing, and after closing we have on half, I think half reset or so. Yes, okay. Now on the half, meaning it's going to check, it's going to set up a trial. Okay, so this trial here, that is on half open. It means it is open, but it is not completely open. It's going to make a first request to see if the server is still has recovered. If it hasn't, then it's going to still open the circuit again. For all incoming requests are going to be blocked. But in case it makes the first trial and it goes through, then all the other service or other requests coming in can now go to the service and return or receive or get their responses. Okay, so that's the usefulness of this circuit breaker, and it's very important, okay, to ease the stress from a server or a service when there's an issue that a service cannot respond anymore. Now let's see how to also implement this circuit breaker. So as usual, I have to make a copy of this, and now down here maybe I can just pass in circuit breaker. So the first thing that we need to do here is to do what? I hope you remember, you know what to do, isn't it? You need to create a circuit breaker strategy. So let's say this is var circuit breaker strategy. From here, so it's equal to new circuit breaker strategy, and we can find that in here, strategy options. Okay, now here we can specify the options that we need from here. Now we have failure ratio, that is 0.5, which is about 50% or 10% of the state. We have sampling duration, and that is the 30 seconds in here. Minimum throughput, and that is the number of time that you want to check. You want to allow requests to come in before it breaks up. Okay, before it opens the circuit. So try the first 3 requests. If they all fail, please do open circuit. Now, when you open circuit, how much time do you want to the open circuit to last for? 30 seconds. That is over here. Within that 30 seconds, no request will pass through. It is blocked. Now, which exception should it handle and open the circuit? That is all exception. So here we can make a specific, maybe when you have server 500, that's the internal server exception. When you have maybe timeout rejection exception, a lot. Okay, so you can specify exception here. But here for the general one, we are generalizing it to all exceptions. And if the circuit is open, that is, if it is open and it is not allowing any connection, we can say that circuit is open for this number of seconds. So that's a break duration second, that is 30 seconds. And if it is unclosed, if it is closed, meaning circuit is now closed, now new call can be made. Now for the testing purpose, this is done by the circuit itself. It is half open. We are saying that it is half open. And now the next call is a trial. So it's going to check if it goes through and it works, then all other requests are going to come in on forth as going to be just a process straight to the service for processing. And that's great. So that's now that we have our strategy created, what we're going to do here is to build a pipeline and now start making a call. So in here we can specify down this, because this is the strategy. And down the strategy, we can create our instance in here as a circuit breaker strategy option. And within that, we need not to, because this we have it already, so we can clear that. So instead of having this, okay, we are also having a retry in here. Okay, so we are also having a retry. So maybe I can get this retry. So maybe you can create an instance of this, or you can create a private which is going to return a retry. Or within this, for us to make another retry, I want us to copy this retry strategy, grab that, and I implement it in the circuit in here. The reason is we're going to make a first call. Now, when we make a first call, when it fails, it's going to retry. Okay, and now here in the retry, we are making an attempt of 5 retry attempts. So 5. And now when here we also going to specify with the circuit breaker, we're going to specify the number of attempts as a throughput, and we said that what we need 3. So we're going to try 5 times. When you get to the 3rd time, that's where this error is going to, the circuit breaker is going to happen. So it's going to break the circuit. Now let's say, now there will be no more call again. So when you make this as even 8 or 9, when you get to the first 3, the subsequent 5 will be executed with no usefulness. So it will make a direct call, okay? Or it will be called, but it won't get to the service that we want. And now the delay here, it is 4 seconds for each. So when it's on retry, you know this already, isn't it? Okay, yeah. So we're going to add a retry. We have a retry strategy stated down here. Then our circuit breaker, we also have the circuit strategy stated. And we can go ahead, grab this, and then pass it on. We are done. All that you need to do here is to make a request with this. So you know, in the V7, that's the version 7 of the Poly, when you have 2 or more strategy like this, or the 2 policies, we call it policies in there. When you have 2 policies, you need to use wrapper. You need to wrap these policies. But here you can see that we are not wrapping the policies. What we can do here is we have an extension that we keep adding. So we can add a lot in here with the same return type. We can group them and now start using. And that's very usefulness, or the very nice and lovely thing about the poly.core. Even the version of what, 8.4, version 8. Good, so I'll entreat you to use this all the time. Okay? Yes, and I believe you love it. Okay. So now let's see, we're going to make a call to this. And now this is going to return HTTP response, no. So let's pass in the token in here. Since you want to return a list, you don't want to be working again, let's pass in the API 2. So we can have access to the one which returns the list of weather forecast. Save this, run this, and now let's check it out. Oh, that's great, fantabulous. We have it ready set. Now let me open this our console. This is our endpoint circuit breaker. Now let's have a look. So I'm going to click on try this out. Now the first trial is not going to hit, so we're going to have on try first, second, third, then circuit breaker will step in. So this is implementing a retry. This is the first attempt. No, it couldn't work sending. Still not working. Let's see the response. Yes, so we have a second attempt. So this couldn't succeed. Second attempt in here. Now let's wait. Oh, this also. Let's see it's going to succeed. Now it is sending. So it couldn't succeed. Now soon I get to the third one. So there is a 1, 2, there's a third one. You can see that circuit is open. And now when circuit is open for 30 seconds, you can see all subsequent requests are not hitting. They are at the back of the connection. You can see on retry attempt 2, 3, they are not executing because you don't see any start processing, right? We have 2, 3, they are at the back in here waiting patiently. Good. So let's see, we have a 2, 3. Now when we check, let's see, because we have 4. Now we made it up to 6. So it's going to execute 2, 3, 4, 5, 6. Maybe 5. because it is starting from 0. So 1, 2, 3, 4, 5. We made answer 8. So we have answer 3 is going to be 7th one. Let's wait and check it out. Okay, so when you go to the 4th one, circuit is half open. Now next call is a trial. So you can see that it opened for 30 seconds. It executed the 5th one. Okay, and it couldn't. So it has to still close it. Now you can see here it did not try for 3. It tried only 1, and as I couldn't succeed, it closed it again. So now it is closed. This is the 5th one for 30 seconds. Now it's still going to execute from the. We made this 8, right? So it has 2 extra left. Now when it gets to 30 seconds, it's also going to try another one again. In case it couldn't, it will keep what? Closing. So let's see. I'm going to try it. So in the execution process. So if we check this, we specified how many times. Okay, this is our retry. It is 8, right? So we need to have 0 to 7 to grab that. So we have the 5th one. So let's still wait while it's making a call to get the 6th and then the 7th one. Alright, so you can see that it also lasted for 30 seconds. It tried the 5th one, half openness, so it's a trial. And now still it couldn't, so it's also 30 seconds. The 6th one is also there. It's going to wait for 30 seconds, make another retry, and now check it out. So you can see that's how it is doing. So it checks out from that the first one on trial. It checks if the call we made. If not, then it's going to close that again. Okay, it's going to open the circuit again. In this case, all endpoint coming in. This is only from one client. The next client also going to execute, also going to be hit, and I don't have access to the resource that he or she needs. Okay, while this on the trial purpose, let's see, let's run the API 2. Now this on try on the 6th one. Circuit is closed. Circuit is open. Now let's see. Circuit will be closed. Will be open. It will be closed for trial purpose. Okay. Now let's see if it will get the content that we want. Circuit. Now we have the endpoint here ready. 7001. Now let's wait for this type. Circuit is half open again. And now when it's half open, a call will be made again. And now by then the server is alive. So we have to get a successful response. Let's have a look. So when you check this, you see there's still processing, isn't it? Let me close all these because these are all the old ones. So it's still processing. Now let's wait and see the 7th one. Yes, you can see circuit is half open. Next one is a trial. And now when you get it, because now circuit is open for 10 seconds again. Let's see, maybe it could not get what. Okay, so it's still requesting. Let's see. So maybe this will take our time. So maybe we can just reduce the size or the time specified down here. And now let's say this attempt is 8. Now in that you wait for maybe 2 seconds each. Aside from that, when we go to our pipeline that we created for our the second that you break for, maybe let's make it as 5 seconds. Okay. Now sample duration, let's make it as 10 seconds. Now let's try this again. So let's execute this circuit breaker. Try this. Execute this. Okay, so let's wait and see. So when we check the console in here, it is still attempting this, and it tells you that although we have this running, but it is not getting it. 7001, it is not getting that, and this is it's not getting this. Maybe let's check it up again and see it well. So from the solution API 2, when you go to the app setting, not the app setting, dependencies or properties line settings, we have the endpoint here as HTTPS as 7001. Great. Now when you go to the weather forecast 2, we are making a call to API 2, and that is 7001/weather forecast. Okay, this is what we have. Do we have this side? Do you have API to this? From API 2, you know this from the API 2, and from weather forecast, we have, okay, there's no API at all. We have only this weather forecast. So maybe I can grab this again. And now from our controller, it is weather forecast as well. So making a code 7025, and you can see this is wrong. So making a call to this, and this supports 7001. So 7001, we have this as a connect to API 2, and that is what we are using down here. So yes, so this is going to work. Now let's give it a try. So let's try this. Now the service is off. Okay, so you're going to have a retry count. All right, so I think the service is already on. So you can see we have the response here. We're going to close API 2. This is API 1, and this is API 2. So let's close this. Now let's make a request again. Now let's check our console. That's we're going to have our retry. Yes, have our retry, and that's great. So let's wait. Now this on the first attempt. When you get to the second one, circuit is going to get closed. So let's see, attempt 1. Attempt 2 is about to execute. Yes, done. Attempt 3, now circuit should open. That's great. So you can see that from the circuit is now open. And attempt 2, attempt 3 is off. You see, as you can see from here, they are not executing. Now, you see this half open, it's going to check, and it's still going to be off because the service is not active. Yeah, it's still closed. Now, let's make the service active. So from the API 2, I'm going to right click on this, go to debug, start with the debugging. Now, let's see, let's wait for a section which is on trial. So we have a half open, it's a trial, and it couldn't. Now, from the attempt at 4, let's see, this new call can be made. Good. So you can see from here, there's a trial. It's not to make the call. There's a starting, and there's a sending. Now there's a receiving. So it has received the response. And as soon as it made that trial, it now make a call as all circuit is closed. Circuit is what? Closed. So all calls can be made through. And now when we check the response, you can see now we are going to have the response in here. Yeah, so that's what we are seeing here. So all calls from the number of throughput that is specified, is going to make an attempt. In case it fails or all fails, circuit is going to be closed, no open. When it's open, no call be made available. Now for 30 timeout from the time that you specify, it's going to make a trial. In case it works, then it's going to close the circuit for all calls to pass through. Good. So now that we have this also implemented, what is the next one to talk about? So what is hedging? That is the next thing that we're going to talk about. Now, hedging is also one of the strategies or the resilience strategies of poly.core. Now, what's actually the function of hedging? Hedging actually helps you to handle scenarios where external services such as APIs might fail temporarily due to network issues, high load, or other transient fault. So in this case, hedging strategy involves executing multiple parallel requests to the same service, usually an external API as we're doing in here, and then choosing the fastest or the most successful response. So let's say we're going to specify if you want to execute 3 responses, you're going to make 3 requests. Now the 3 requests that you're going to make is going to choose the fastest response in our display. So here, the motive here is to check if the service might fail, then make a multiple request. And maybe by the multiple requests that's going to make, at least one will pass through. In case all pass through, then check the fastest response and I'll return. So that's the hedging. Let's see how to introduce or implement this hedging strategy. As usual, let me grab this. And now let me just do what you've done. Okay, that's what we've done. And I'm going to say this is hedging. Okay, now let me open this. And they all have the same return type, right? Okay, so the next thing we're going to do here is we need to implement our strategy first. So let's first create a hedging strategy. Now, since we're going to check, this response is going to come from an HTTP response, because from the hedging, we want to check a specific status, and I'll make a multiple calls again. So in that, we want to handle an exception whereby the result here it is an internal server error. Okay, so here we are also making an explicit exception that we want to call multiple times. I hope this is clear. Good. So now let's see. Now we're going to create our hedging. So let's say this is var. This is hedging strategy. That's equal to new hedging strategy option. And in that, we need HTTP response message. Now, within our response message, we can now specify the following properties in there. So it should handle our response, HTTP response message, found in any exception, which has a result of what the status code is for internal server error, that is 500. Now the maximum head that's supposed to make a call to is what? 3. Delay for making each call, it is 1 second. And now here we are having this action generator, that is in case it's about to, then preparing to execute hedge action. When it is on hedging, when it's executing, then we can specify the attempt number, because here we're making 3 attempts. So we can get attempt 1, attempt 2, and attempt what? 3. Good. Let's implement this in our pipeline. So here, all that we need to do is to create a pipeline and now use the hedging that we created. So hedging strategy, we grab these and we can pass it on in here. Let's remove this. Then we can see this is hedging pipeline. Then let's use this hedging down here, because here we are returning HTTP response message. Okay. And now with this, you can see we execute the token. So here we're executing it straight ahead. Or, this message is returning HTTP response, right? This endpoint. Where is it? We created 2 endpoints which are executing, yes. So connect to API 1 is executing what? HTTP response message. So we can call that in there, or we can execute it straight ahead as well. So maybe instead of this, we can also call this in here, like this, and it's still going to work. Or you can specify it straight ahead in there. Now we're checking if data is equal to success, or if the status code is success, then you want to read from the response that has been received, and I return the list. In case it isn't, then you want to return the status code of that. Good. Now let's see. So let's run this and check this out. Alright, so it is ready. Now we're going to execute a hedging, and that is this one. So hedging, let's execute that. Before that, let's make our this visible. So click on, try this out, and now execute. Now our service is off. So let's see, you can see on hedging is attempting. So preparing to execute hedging action. Then on hedging, attempt 0, attempt 1, attempt 2. And so it couldn't retrieve the message. Okay, so it means the server is off. Now have a look from the response that is getting to us. So when you check it here, you can see that we have this response. No connection could be made because the target machine refused it. And that's what we have in here. Now we are returning the status code in case you couldn't. So watch here. From the response that we have in here, it is returning the status code of 500. Now there's the status code that's going to return, as you can see from here. And now there's a custom message from our exception handler. And now there's the actual message from it. So you can see that it made 3 attempts. Then it will choose one in case it's working. Okay, but it's not working. So this is what you're going to do. We are going to, let me on the API to the server, or the service. There's a service, not the server. Although we see it here, but it's a service outside that we don't know. We are making a call up to. All that you know is the URL, right? The address. Now let's try this again. Let's make sure both are up and running. So from the face here, let's execute once again. And now watch here. You can see that here it's making a request. Now you can see we have sending, first request. We have sending again. So you have it from here. Start processing. We have sending. Then we have receiving. Now let's see. So we have the response from this. Okay. So we have there's a response that we have. So this is a receive response that we are having down here. Okay. So in case it could not connect to the server, it's going to retry and get us the fastest. So in case it does too, then it's going to give us what we need as well. Okay, so that's the hedging, and we can use that as well. All right, now let's talk about the last one for this video or for the day. And that is a rate limiter. Now, rate limiter, it is a technique that is used to restrict the number of requests made to an API or service within a specific time window. And it prevents an excessive traffic, whereby protecting the server and ensure fair usage among clients. So, now with this, you can specify the number of requests that you want the server to handle at a time. And aside from that, in case you have that request and there's a new request, it's going to queue that or reject it. So in this case, you can preserve the server from overloading or from crashing. Good. Now that we have this, we are not going to use the poly. Poly also has its way of implementing this, but there's a default package in Microsoft, and that's what we're going to be using in here. Okay. So we're going to use a default rate limiter from Microsoft, and this I think is available from version 7. Yes, from version 7. And now, so talking about version 7, version 8, and the feature versions. Now this is default, and you can use that in. So there's no need for you to use any external package again, like the poly or the poly.core. Now let's see. So this, we're going to implement this in the service. So let's say this is the service, the API 2. Now in that, we go to our program.cs file, and that is where we are going to implement this this rate limiter in there. There are 4 types of rate limiter that we can use. We have the bucket token, or that's the token bucket limiter. We have the concurrent limiter. We have fixed window limiter. We have sliding window limiter. Okay, we're not going to talk about any of all of these. We talk about the essential and the current one, or the one that you can use, the flexible one. Okay, and that is the token, the bucket token, or the token bucket. The token bucket limiter. Now, what actually does this limiter do? This here, the name implies, the name here is what? The bucket of token. So if any request coming in, it goes to the bucket and now assign or pick a token from the bucket. So all requests coming in are going to have a token. Okay. Now, when the token in the bucket gets finished, if any request comes in and decides to go in for a token, by then there won't be any token. So that request is overloaded. It's overload. Then it has to move it to the queue. In case you want to specify a queue, it has to move it. But in case you don't want to specify a queue, then it has to reject it until the tokens are, until the new request, until the all requests which have tokens have been processed. And now we can also specify the replenish time. Let's say the time that you want to refill the bucket with another token. So every 30 minutes, when the token gets exhausted, I want to use 30 minutes to fill it again. So every 30 minutes, the bucket is going to be full. Every 30 minutes, it's going to be full. So within that 30 minutes or 30 seconds, all requests coming in, if they are 30, it's going to have token and I get executed. In case they are less, there also still be an extra token. And now with every 30 minutes, there's also going to be another token which is going to be added to what we have in the bucket already. So at the time, there will be a full bucket of token, unless the request comes in subsequently so that the token gets exhausted in the bucket. That is where you have to wait for 30 seconds for another token to be added before these processes or these requests can be processed. Okay, so in order to do that, we have to add the token or the bucket service. And I know that's what we are doing. So build the services.add rate limiter. This is default one. And now here we are adding the token bucket limiter. So we give it a name that we're going to be using or retrieving to apply to the controller or any action method in the controller. Then we're going to have it as auto replenishment time. So time that you want is to get the token, you want the token to get filled in the bucket. Set it auto through yes. Now what is the token limit? So anytime, pass it on only 3 tokens. So it means you're going to accept only 3 requests at a time. Now what is the token per period? So what is the number of tokens that you want to get filled in the bucket per period? It is 3. The bucket is taking 3, and now per every period, I want us to add 3. What is the queue limit? So here I'm queuing 2. Okay, and now from that queue, I want to, if I'm processing the queue, I want to start from the oldest, the first queue that came, and the latest queue will be the last one when processing. So first come, first serve. And now what is the replenishment period? So how many or how much time do you want to refill the token, the bucket with token? That is a limit of 3. That is every 5 seconds. Okay, so now once you have this, let's see. Now this is when reject. Maybe you can use console.log to log this. And now here it's having an this is an event that can get called whenever a token is rejected. Token can be rejected when the queue limit is 0 or the token this limit exceeds. When the queue limit exceeds 2, then all subsequent requests are going to be rejected. And in this case, this can get called. Okay, when token is rejected, this status code is going to be released. That is 429, too many requests. Alright, so we're going to set here to 2. And now when we are done, when we try this and it works, we're going to set here to 0. It means we are not queuing any request. Then let's see that this status is going to get called. Okay, so once you have this, the next thing we're going to do here is we're going to be using this in the controller to protect the specific endpoint. So from the only controller that we have this bucket token. So we can go in there and now implement this. So let me copy this. Let's go to our weather forecast from this weather forecast controller. And now in here, we want to enable rate limiting. So enable rate limiting. Now in that, specify the limiting that you created. That's the bucket token limiting or the limiter. Good. So once that we have this, let's see. So this is going to allow 3 requests at a time. And you're going to queue 3. Good. Now let's go in there and make requests to this. So how do you make requests to this? You're going to make a call to this. Okay, so let's go to the endpoint. And now from here, let's create another endpoint to make request. So maybe I can just grab this from here and now down there. Let me minimize this. Also this and that. Okay, and now in here I'm going to say this is rate limiting. Now let me also have it same. Then I'm going to say this is var. Okay, so let's say this is results is equal to, you can have an await. Then let's call this. So connect to API 1, and you can check if results dot success status code. Then we want to return. Okay, and now here we're going to have await results dot content dot read from JSON async, and that we can specify the enumerable of this weather forecast. So else, what are we doing? We want to return maybe bad request. Okay, so else you want to return this bad request. Okay, or we can return the status code from this. As for this, you can manage it to suit what you want. But what you want to focus here is that all these requests are not going to be executed when it exceeds 3. For us to get the request, or that's a status code, that's a rejected status code, or too many requests, as a 429, let's return maybe status code. And now this status code, you can pass in this result dot status code. And now since this, we need to typecast this as what? Integer. Okay, so now let's run this and check this out. So let's make sure we have API 1 and API 2 both running. So there's an API 1, as you can see from the title. There's an API 2. Okay, now from API 2, let's try and see if you're going to return a list of weather forecast. Great, you have it. Let's go to API 1. And now from the last one, rate limiting, let's execute this and check it out. So from here, you can see we're executing it, and now we have the content in here, right? Let me minimize this more. Okay, now I'm executing this. So I'm going to execute this simultaneously. Now we need to execute with more than 3, so check it out. So execute this 3. Now you see we have this. You see? So when it exceeds 3, now wait. First one, you get executed. 2 executed. 3, get. Now let's see it. Now that's what we're going to do. It's going to queue that. I want us to increase the time so we can see this well. So let's go to our program. Let's set this, the queue limit here, to 0. Now let's save this. Let's run the API 2. And now we are using this in the bucket tokens here. Inside this weather forecast, that's the API 2 weather forecast, and that's the rate limiting that we are using. Okay. Now let's see. So it's ready. Now let's execute this. So we need 3 times. So you can see. So when you execute this simultaneously, it gets stuck. So I believe after the request, it should have, because since we have the queue limit of 0, it means there shouldn't be any queue. And if there shouldn't be any queue, then it has to reject it. And we have to get a status code, but we are not having that. Do you see this? Maybe there's something wrong here. Yes. It's time for us to debug our code and check it out. Good, so let's see from this. After we are done with this, we add a rate limiter. Oh, okay. We did not use that. So app.use rate limiter. That's great. This is what we missed. So we are not using it. Now let's run this again. And I'll run our API 2. Okay, so we're going to run our API 2. Now, since you're having the rate limiter to, or the queue limit to 0, it means you're not queuing anything. So aside from if the server or if the service takes the first 3 response or the first 3 requests, the subsequent ones is going to discard that until this is the time period that we specified. So let's say this time period we want to do this as maybe 10 seconds, okay? So that you can just put in a new token for a new request. Okay, let's do this again. Alright, so let's give it a try. Now API 2, API 2. Let's see our API 1. Now rate limiter, so it's going to accept 3. So let's say you want to click on this one by one for some time, and you just press it again. This is not going to work. But when you click on this, when you make a request simultaneously, that is where this gets executed. So this is the first one. The second one, you wait for some time. Then we can now click on it again. Third one. Now let's see the fourth one, and it's still going to work. Click on it, and you see now we have it. This is the fourth one. Now let's issue request simultaneously 3 times and check it out. So 1, 2, 3. Now let's check it out. We have the response in here. Okay, yes. So you can see that since you're not having any queue, it took our first 3 requests, and after that it rejected the subsequent ones. So you can see I have 429, and this trace ID with the status of 429, which tells you that too many requests. That is the status, so that's the meaning of that. Now when you wait for some time, it's going to replenish the bucket with full of tokens again, and the subsequent requests also go again, because now we have it. So if let's go to inspect element here, and now from our network tab, if I make a request, because we have it in here, and this is going, status code is for 200. Now check it out. Now it won't go. So let's see. You can see the rest are not going for some time, and the other one will go. So once I made this subsequent request, you can see that some of them are rejected, others are passing through when the time is up. And when the token or bucket are full of 4 tokens again, then the next is going to get executed. You see? Yeah, so this time the server can now have some time to breathe, can have some time to process a new request coming in, and it can close all those popping inside the room for processing. And when at its own time, you can now go ahead and now make a request to them or serve their request that they want. Alright, so in this video, we've covered, I think, 6 techniques that you can use to implement or to boost your API by creating resilient and now robust. We've seen how to apply the retry technique, how to apply timeout technique, how to apply the fallback technique, how to apply a circuit breaker, and lastly, how to apply the rate limiter technique. Yeah, this concludes the video. I think we spent about more than an hour now, so I'm going to end here. I believe you've learned something, and you can now boost yourself and now implement a real API project which is strong enough to resist to any issue that may pop up against it, okay, by implementing any of this. It is not mandatory to implement all of this in one API project. Based on what you need, you just implement in there, and now off you go your way. While the project scales up, you can actually add more to it. Caching, it is a technique that you can never skip if you want to create robust and a resilient API. I'm going to take you through how to implement this caching in your web API. You know, in .NET, caching is a critical technique to improve the performance and scalability of application by temporarily storing data that is expensive to retrieve or compute. Data in your API or access points in your API that are often or frequently accessed, you can cache them to reduce the load from the server. And in that, there are several caching mechanisms available in .NET. There are a lot. We have the output cache, we have iMemory cache, and we have system.runtime.caching. Now, these 3 types of caching, we're using them as an in-memory cache. Basically, there are 2 types of caching, that is a distributed, and now we have the in-memory caching. Now, under the in-memory caching, the following that I mentioned are the types that we can use, or the technique that we can use to cache. So in this video, we're going to have a look on how to implement the output caching, and also how to implement the distributed caching. So simply to explain this for you to understand it in just like one line, what I can say here is when we talk about in-memory caching, it is where data is stored in the web server's memory, making it very fast to retrieve. Okay, and I want to talk about the distributed caching. That is where you have a separate server which holds the cache for all requests, or all servers go to that server and now check if there's any cache data in there, then return to the user. If not, then process a new request, cache it, and I'll send it back to the user. I believe this is the most simplest explanation you've ever seen, isn't it? That's great. All right, so we are going to have a look on first how to implement the in-memory cache. You know that the in-memory cache, this data has been kept in the web server's memory, and that's why we say in-memory. When the server closes down, the data is ripped off. But when you take a look at the distributed cache, this cache is stored on a different server. So even when the web server is off, the cache still maintains. Okay, and let's see how to implement the in-memory cache. So I have a project created already, and that is a demo resilient and a robust API solution. I have made a couple of videos in here how to implement all the poly strategies. So I have made that as well available in the video description, so you can check it out and now look at the ways that you can improve your API communication by implementing all these strategies as well, making it robust and resilient. Alright, so I have a simple solution created and I have two projects added in here. That's an API 1, API 2. We are assuming that API 2 is a service that you're calling externally. Okay, so this is not part of our API. We are making a call to that. Although it is here, but assume. Yes, assume it. Alright, so this is what you're going to do. Now, I did not do anything differently. It is a normal default stuff that we have in here. When you take a look with the API 2, that is our service, you can see that we have a controller created, and that is a different thing. It's a normal thing that we're doing. You know, here we are having this endpoint here that is getting you the weather forecast list. Okay, so this is the rate limiting. We've done that already. So if you don't know that, you can check this video description for that video. Okay, when I'm done with this too, I'm going to combine the videos again together as one, so you can watch everything for you to create a resilient and a robust API from start to finish, and you're going to learn a lot in that video. Okay, so for now we are not implementing any limit, so let's clear that. So if I run this API 2, let's see the default stuff that you and I know defaultly. Let me just run this and now let's check it out. And our API is ready, as you can see from the screen. Now we have our API 2 opened, and I can see if I click on try this out, we have this weather forecast as a list of 1 up to 15. Yeah, that's the 15 list. Yeah, so that's a simple thing that we're doing. Now we're going to consume this as a service from our end API 1. Okay, so let's see from an API 1 to this what we have in there. So in the controller, this is what we are doing. From here, I can just close. These are the strategies that we spoke about in the previous video to make your API robust and resilient, and so that is it. We are not focusing on this today. What we are doing here is we're going to create another endpoint, and now in this you see that from here we are just making a call to this endpoint. Okay, so even with this is what I can do. I can just grab this and I'll create a new endpoint in here. Let me put this endpoint on top, and this is going to be HTTP GET as well. So let me make this as caching, and this is public async task. Let's use the interface of iAction results, and this is the name of cache. So within this is what we are doing. You're going to return, let's say okay, then in that we have await. We have HTTP client instance injected, so get from JSON async. And now in here, maybe we can convert this to enumerable of weather forecast. Okay, so we are just returning this await. Then we have to specify the route in here. Okay, so it means we have to go in there and I'll copy only the link. So we grab this, then in here we can paste it on here, as you can see. Okay, so we are getting this from this weather forecast endpoint as a service, and that is this service. So when we run this, then we can have access to that 7001 as a port, and that is the same thing applies to this API too. Okay, now let's test this out. So from here, let's run both projects, and now check it out. So here I'm going to configure startup project for the 2 and multiple startup. I'm going to start without debugging. Then let's run the 2 projects. You see it is ready now. So this is our API 1 and that is our API 2. So you're going to make a call to this service. You know this service is active. So let's say from caching, let's try to get this data from this API. And that's what we have in here. So we have all this data from this API 2. Let's say our service, and that's great. But I could say if I click on this, go to inspect element, and let's see now, because this is the first time of getting the data, so we assume or here is supposed to get cached, so that anytime that I make another call, we don't populate it again. But look what's going to happen. So if I click on this, see it is still getting it in here. You can see it used what 59 milliseconds, okay, to get this from this API. So this is what we're going to do. Let's introduce a delay to this, so we can use this to explain what this concept for you to understand it into details. So yeah, after, let's see. All right, so before we do this, we have to then store this. Let's say this is var data is equal to this. Then we can now return. So let's remove this. We pass in this data in here, and then we can now close this peacefully. Okay, so we want to introduce delay to this. Okay, so maybe http dot, yes. Now let's introduce delay. So we're going to say await task dot delay. Let's introduce 3 seconds in this. Now let's run both projects again and check it out. So they are ready. Now right click on the API 1. Let's go to inspect. We go to the developer tool. Then we want to check this network tab. That's going to record the time that is going to be using for making a call to the service. So from the first initial call, let's say we are delaying for 3 seconds. So we're going to wait for 3 seconds before it gets the data from that service. So we took what 3 seconds and 52 milliseconds, right? So 3.52. Now, when we make another call again, you can see it is still the same waiting for the same 3.52 seconds. Now, you can see there is 3.06. So that 3 here, it is constant because we are delaying for 3 seconds. So let's see, this is going to give us a 3. Let's see. Yes, so 306. Let's again, 306. So you can see that this is keeping on delaying, but the same data, that's what we are making a query after calling this endpoint to retrieve. So can't we cache this so that it will reduce the number of request time or the processing time, and also it will save or it will free the server or the database? Yes, we can. And that is what we're going to implement, the in-memory caching. Okay, so let's see how to implement it. Now, this in-memory caching here, it is coming from this default Microsoft framework, and here we can have this output cache. It's also one way. We have the iMemory cache. You can use the interface, or you can use the output cache. So I'm going to introduce you to the output cache. And implementing this is very, very simple. Very, very, very simple. Trust me. You're going to love this when you see that. So go to the program, your solution in there, and actually we want to implement it from the API 2 because that is our service. So any request that comes in here, we want to cache the processing of the result first, so that when a subsequent request comes in, we're going to release the cache data instead of going to the database and now populating it. Release the cache data. Okay, and now for this cache, it has time or expiration time. So when the time is due, it's going to clear that cache, and now anytime there is a new request comes in, it goes to the cache, and since there's no cache data in there, it goes to the database, populate it, and I return, and then cache it, and then give it back to the client. So at the time, you're going to have an update content in there. All right, let's see. From our service, from the API 2, you go to your program.cs file, and in there we need to register the cache service first. So in order to do that, you have to specify it builder.services. So dot add output cache. And now after doing that, you have to implement or have to use this middleware pipeline, and that is an app dot so use output cache. Okay, so now that we have this set and done, we have to add a service and add the middleware pipeline. Good. So now that we are done, what we're going to do here is we go to the API 2 as a service controller, and then here we have this. So we want to cache this. So in order to cache this, what are we doing? Let's see. So we're going to introduce the delay here. So I'm going to grab this from this here. Okay. So the right thing that's supposed to do here is to implement or introduce the delay on the service. Okay, so here, that is where the delay is supposed to happen. So let's see, and this is still going to work. Let's make it as async. This is task. And aside from doing this, so this is what we're doing. Like when we try this, it's going to work. It is the same. Let's see. Okay, so let's give it a try from the cache. We are delaying 3 seconds, so take note. Now the request is going in, and now let's see the response. It took what? So 3.59 seconds. Let's clear this, call it again, and it is still doing the same thing, going to take in the same 3 seconds point something. So let's wait and see. 3.11, the same thing, and now we are having the same result as well, 3.07. So 3 is a constant because that is what the amount time or delay time that we have specified. Now the reason why we have to delay here, it is a service. So let's assume the service takes much time to populate or compute the result. So in this case, it's going to delay. That's why we're introducing the delay in here, not in the client. Now this is a client. So when you delay here, let's say the service does not delay and this client delay. It doesn't make sense, okay? So you want the service to now get delayed. So when this get delayed, that is where it tells you that it's computing volume of data. And when we delay, we can also cache it so that when we get to start or when we get to try this, it won't delay. We're going to have it in a fast way of retrieving since it's using the cache instead of populating or computing it again for us. Good. So now that we have the service injected, we have the middleware pipeline being used. Now what we're going to do here is we're going to introduce the output cache in here. Now let's see. So output cache, implement this attribute. And now this attribute, there are a lot of parameters that you can specify. Have a look. So you can see here we have duration, we have no store, policy name, vary by header names, vary by query keys, and our route value names. What does each mean? For duration, you know what duration is going to happen. Now it's going to detect or tell the output cache the time that you want to keep this data for. When the time exceeds, it's going to clear the cache away. Now no store, when you set this to true, it means you are saying that this output cache shouldn't cache the content that you want to retrieve it from this specific endpoint. Policy name is maybe you have a specific configuration that you're going to do. You can do that in the program.cs file, and now you can use that policy in here. And also we have the tags. So the tags can be used to cache it based on the tag that you provide. Vary by header. When you have a special header that you want to cache, based on that, it's going to cache the content based on the header that you're going to specify. The same thing applies to the query. When you have a special query key that you want to cache it with, it's going to cache the content based on that key. And now when retrieving, and for the last one, when you have a special route value that you want to cache this with, then you can also do that. But what we are interested most here is the basic one, and that's why we need the no store. You're going to set this to false. I'm going to set the duration to maybe 30 seconds. So let's have duration set to 30 seconds, and also some no store, we set this to false because you want to cache this. Okay, now let's see. So this is going to be cached. The results that are going to have here are going to return from this, going to be cached for 30 seconds, and after that it's going to get cleared off. So any request or any client that make a request to this within that 30 seconds is going to retrieve the cached data, not the data from this. Okay, so maybe we can let's see. Let's run this and check it out. So let's click on this to run this up. So now that we have this caching implemented, let's see. So I'm going to make a first call. Now this first call is going to take 3 seconds, okay, because that's the delay time that we have specified. Now if I click on try this out for the first time, see it is pending and it's going to delay for 3 seconds, and I check it out. So it took 3.54 seconds. Now from the subsequent request within 30 seconds, let's see what happened. Click on this and I can see we have it. Now it took 104 milliseconds, and this is the result is from the, I'm doing screen recording and etc. So that's the delay that you're having. But we see this is milliseconds and that is seconds. So from subsequent ones, you see 46, we have 48. All these are milliseconds until 30 minutes elapses or 30 seconds elapses. All subsequent or client requests are going to returned or served by the cache. So let's see. As soon as 30 gets up, you can see that it clears the cache, and now you need to make another call again, and I have it in here. So you can see this cache is working. Good. This is automatically populated and managed, because here you cannot clear the cache manually. Because when you have a look at this, although we have specified this 30 seconds, so within that 30 seconds, in case maybe you want to clear the cache manually, how can you do this? Output cache does not have direct remove implementation, so I created a wrapper to wrap this, and in that I made it possible for you to delete it, to clear the cache and now delete it. So let's see how to also use that. Okay, it's a package that you need to install to manage this. So in order to use that, what we're going to do here is we have to install this package to the service. So right click on dependencies, and I'll go to manage NuGet packages, and in that we're going to type in for netcode. Yeah, so when we have the list here, the package that I have created, we are going to look up for this one. So that's a netcode-hub.packages.wrappers.output cache. So this is what you need to install. So install this package. The current version here is 1.0.1. So install this package in here. Then I just uploaded it yesterday or so. Yes, you can see Friday, May 31st. Yeah, so we have this package installed. Now let's reboot the project. Okay, so succeeded in building. So we have this already. Alright, so the next thing that we're going to do in here is, let's go back to our program. So instead of us having this service registered, no, I did it. So we're going to remove it. And also from the pipeline, we're going to also remove this one. So this is what you're going to do. We're going to be using the package service. So this is .add Netcode-Hub. So output cache service. And now this is coming from this package. So netcode-hub.packages.wrappers.output cache. So you add the service, and now from the middleware pipeline, so app.use netcode-hub output cache. So you specify this here. Okay, so now that you have this, you can then go ahead and implement this by having the set, get, and remove method. Now this package has an interface that is the iNetcode-Hub output cache, and that interface contains the 3 methods that we can use to manage the cache. So let's go to our controller from here. Now instead of having this attribute specified on top, we're not going to do that. What we're going to be doing here is, when we have the list from this, we are going to store this in here. Okay, so data is equal to. So maybe when we make a call to this, first you want to check if the data exists. So we're going to say that maybe weather data. So this equal to, then we can have access to this await. But before that, let's inject this. So maybe we can use primary constructor in here, and I'll remove this. Okay, let's take off this iLogger since I'm not using that. So there's an Netcode-Hub cache. Let's give it a name as Netcode output cache. So now that we have this, we're going to say that await this dot, then we can have access to, you can see we have remove cache, get cache, and now we have set cache. So we have remove and that's a set cache. So here we want to get this cache, and now this takes in the key and now the cancellation token. So what is the key in here? The key that I want to specify here, it is a, let's say this is weather data, and now let's specify a cancellation token. Token.none. So this is going to return string. So we need to deserialize this. Before that, we can say that if string here dot is null or empty, and here we are referring to this weather data. So either return here it is not equal to empty, then return, we need to, let's say this, okay, then let's use JSON serializer. So serializer, and now this is coming from, we can have access to system.test.json.serialize. Now here we're going to deserialize this, and I'm going to deserialize it as an enumerable of weather forecast, and that is all. Then here we specify this weather data in there. And you know, this we must have, we can decide to use the interface, or we can decide to use this action result. So action result, then let's close this up. Yes, so we have this. So in case it is not now, we want to call this else, then we want to delay and then call this. Now after we've called this, instead of us to return, no, we're not going to return, we're going to wait, then let's cache it. So this is get cache, and now after we put in the cache is empty, we get the rare content from the database, then here set cache. So let's set before we return. So after that we can return okay with the data that we have, but before we return the data we have to set this cache. Now in order to set this cache, what we're going to do here is await. We're going to be using the same Netcode-Hub cache.set cache. Now this set cache, you need to specify the key. So what is the key? You make sure the key is the same as what you used to get. Then we have to specify the data itself, and now we're going to use the same JSON serializer.serialize this as a string. And now what is the content in here? That is the data. The data, that's the weather forecast list that we have in here. After that, what is the time span that you want to hold it for? So let's use time span dot from seconds. You want to maintain the same seconds in here, so I'm going to pass in 30 seconds. Okay, then aside from that, we need to specify tags. So tags is, let's say this is null. Maybe tags are used to maybe group them in the cache, but for now let's maintain it as null. And aside from that, we need to specify cancellation token. So we have cancellation token dot none. Okay, so this is what we have in here. So let's arrange it well for you to get this. Now this is the cache key. So cache key is this one. Now the next one here, it is the data. So this is the data itself, and also we have that is a valid. This is supposed to be the tags. So tags, this will be null. Yes, then we have valid for, and we have the cancellation token. and that is a cancellation token that we need to specify in here. So let's see. Yes. Okay, so these are the properties, or these are the parameters that you need to specify: the key, the data, whereby you serialize it into a string. Then also we have the tags, we have the valid for the time or the time period, and the token. After that, we cache it, and now we go to return this. Okay, now this set cache is going to return a tag. So yeah, in case there's any issue, it's going to throw it, because I surrounded that with try catch. So in case there's any issue, it's going to throw this, and you can also use try catch to retrieve or to get the data in case there's any issue. But with this, it's going to work, so don't worry. All right, so now that we have this, let's also have another method to clear the cache. So here we can have public, and this is just an async task. Let's implement the iAction results. This is clear cache, and now within this we want to return, let's see, no content. Okay, but before we return no content, I think we have to clear the cache first. So return no content. But before we return no content, we have to make sure that we clear the cache. So Netcode-Hub cache.clear or remove cache. Then what we're going to do here is specify the key. So that is the weather data. And also, in case you have cancellation token, let's also specify the default one as none. And this is going to get the cache cleared. Yes. Alright, so now this is working. Let's see if this is going to work. Okay, we're going to try this. Now in the course of 30 seconds, whereby the cache still persists, we're going to clear the cache and now make a call again and check it out if the clear cache is working. If not, then we look into that again. But trust me, this is going to work 100% for you. Okay, so it is ready. Now I'm going to clear this. And also, once you're done, I'm going to clear this. So let's record the time you're going to be using here. So with this, we're going to execute this. And now here, we wait for 3 seconds. Since the cache is null, it is waiting and getting it from the data or the SQL database. The next call is going to get it. So 121 milliseconds. This took 3 seconds. And now execute again. Now you can see, until the 30 seconds elapses, it is still going to use the cache. Now let's click on it so the 30 seconds elapses for a new call to be done or to be made. And let's check it out. And that call must use 3 seconds and above. So let's see. Yeah, so you can see that we have it in here. Alright, so once you have this, we're going to, now you can see next call is very quick. Let's clear the cache here and I'll check it out. So I'm going to clear the cache. It seems you're not having this cache cleared in here, do we? Let's go through and have a look. Okay, we did not specify any header on top, so no HTTP verb. So this is, let's assume this is get, and then here we're going to say that this is clear cache. Okay, now let's restart this again. So let's see. All right, clear this. Now make a cache, clear this. So let's get the content again. Now the next subsequent request, you can see we are having this working. Let's clear cache and see. Okay, I'm not getting it. Okay, so we are implementing that in the API 2. Yeah, so this is the service, and we are implementing this in here, and we are going to call this endpoint to clear the cache, right? So in order to do that, maybe we can try that in the client, but for now, let's try that in the that's the server itself. Okay, so from here we have the API 1. We're going to introduce API 2. We have this the clear cache. So for the first start, right click on this. Let's go to inspect element. Let's click on this network tab, and now we're going to make a first call to this weather forecast, whereby it doesn't cache any. So it's going to get it 3 seconds, 0.2. Now execute the next one, 52 seconds, a millisecond. You see that is it. Now let's clear the cache here. Now check it out. So click on this and now clear cache. Nothing happened, and I'll make a call again, and I can see that it is now calling the same endpoint again, right? So get it, you can see this working. Let's clear cache, cleared, and now let's get the content again, and you can see it is still waiting. So that's a way to manage. So you can see this wrapper actually helps you to clear cache, set it to any time or anyhow that you want to be to do it. Okay, now let's consume it from the client. You know, the endpoint that you have in here, it is a clear cache, and so let's grab this. It's a get, and now that's a controller. So when you go to this for that controller in here, we can make a copy of this. And now we're going to say that this is clear. So weather forecast / clear cache. Okay. And now in here, we're going to say this is clear cache. And now, let's say clear cache. That is all that we need to do. Now this is going to return no content. Okay. So maybe it's still going to work. So return no content or return okay with the data, or return no content, anyone. It's still going to work. Let's see. Let's run this up and check it out. So this is also ready. Now let me clear this. You see we have this a cache. Let's get a call. So we're going to populate it now pending for 30 seconds, 60 seconds. Subsequent one are cached. Now let's clear the cache. So clear this. And now here we are having response of 500. So internal server error from this exception handler. Okay. So there's an issue here that we need to check it out. So what is an issue that we are getting? So let's check from here. Alright, so you can see when you check, it is returning no content. You know, this cache is returning no content. And here, so maybe let's return okay. And now since this is returning okay, we cannot, and it's returning just an I action result. So when you go to the controller in here, you can see I cannot return this. So this is get from. Let's use get async for this. And that is all. So return okay. Alright, so now let's run this. Check this out again. Okay, so it is ready now. Now from the caching, let's see. If I click on this execute, I'm going to get the new set of data again. So we are making another query, a new query. Now once you have it, it's going to be, that's been cached already. So subsequent once you have it. Now let's see from the clear cache, try this out, clear this, that's been called. And now let's see, as soon as I click on this, you're going to get a new one again. Yeah, so you can now clear the cache. You can also set the cache. You see? Yeah, so this wrapper actually helps you to manage the cache on your own. Good. All right, so that is one way of implementing the in-memory caching. There's another way that you can use system.runtime.caching. Then you can also use the package introduced in there already. You can also do that as well. But actually, there's also one. Then let's say distributed caching. So distributed caching in .NET Web API refers to a caching strategy where cache data is stored in a distributed cache system, which can be accessed by multiple instances of an application, often running on different servers. So distributed cache system often runs on its own. This approach is particularly useful in scenarios where an application is deployed across server farms or cloud environment, ensuring that all instances of the application can share the same cache data. So each doesn't have to cache its own data. No, all the data has been cached at one central place, and all of these instances can have access to that data at once. Okay. Now, what are the key benefits of using distributed caching? The scalability is reliable, it improves performance, and consistency. All the time the data is there, as soon as it is cached, and all instances can still have access to. There are a lot of providers who provide this distributed cache system. We can use an SQL server to handle that. You can also use Redis to also do that. You can use an Ncache, you can use Memcache, and even for trial purpose, there's also an memory distributed cache provided by Microsoft, and you can use that. It's already included in the system, so you can use that. But that one is not advisable to use that. It is also it is just used for testing purpose. Okay. But in this, I'm going to show you how to use this Redis to actually hold cache data and now serve it onto servers. You know, I said earlier that Redis is one of the cache provider. You know, Redis is an open source in-memory data structure store used as a database or cache and our message broker. It supports various data structures such as string, hash, list, set, sorted set, with range queries, and a lot. Okay, so in short, Redis is an in-memory data or data store which can hold our cache for us. And now this runs on its own server. So even when your web API is down, this server is still available and the cache still persists as far as the time or the expression time is not due. Alright, now how do you run Redis here? Before we do that, there are several ways to run this. You can use the WSL, that is a Windows subsystem for Linux. We can also use Docker. I hope you've heard of Docker before. Yeah, we can also use Docker. And the last one, we can also use Redis for Windows port. So in that, you're going to be using Docker since it is easy to use or easy to implement. So since Redis is going to run on its own server, we need to make this server available, right? So that's the reason why we're going to use the Docker to run this Redis. Now, just pick your browser and now go to just Google and type in download Docker desktop. So this is a site that's going to take you to, and now just Docker desktop, you can just install this app from this section. I have that already, so I need not to install this again. Then I'm going to launch this app. So you know, when you run it, you have to install the app, and when you run the Docker desktop, you can see we have to check here, engine is running, right? So this is running, this is active. So this is what I'm going to be doing. What we're going to do here is we're going to install this my Redis image. Okay, so how do you install this? Let's open PowerShell. So window PowerShell. Then in that, we're going to start with that. So here, this is what you're going to do. First of all, to check if Docker is actually installed, yes, although you have the view, you can just type in docker version, and you're going to see the Docker version that is 28.0.0. okay, and in that we are not actually looking at this section. What we need to do is install this our image. Okay, so just type in docker run. It's going to download it and run it. Now you can specify a name to this if you want, and now this is my Redis. Give it any name at all that you want. And also we have the port. So default port is 63. Instead of P, see what I did? Yes, don't do that. Yeah, so 6379. That's the in, and we have the out as also 6379. I'm going to repeat the same port as well. Okay, so now that we have this, we have detached. It means you don't want to see the running session in the console. Do it at the background for us. We don't want to see that. All that you need to do here is you want to see this run. Then the image name is Redis. Make sure you type it correctly. And now when you're done, hit on the enter key. Alright, so unable to find this latest locally. Alright, so let's see how to go about this. Alright, so you can see that here it is downloading this, and now please you wait for it to get downloaded. Then we can now move on. So let's say it's almost done. You can see we have only one left. So this will just download it and I'll run it because we made a Docker run. Okay, so to see this, you can just type in docker ps, and which will give you all the images which are running. Good, now we have this. It is running 42 seconds, and there's a port. So we have our in, we have an out, 6379, and the name is my Redis. Alright, so this is what we need, and this is a local host, isn't it? We have our port in here. Good, so while this our server, Redis server is running, you know, configuring is very simple. You see that? Yeah, very simple. It's amazing. Okay, so now we can now go back to our application. So let me put this on the second screen, although you cannot see, but as for me, I can see. It is not closed, it is live. Okay, so now that we have this set, what's the next thing to do? We are now going to install a package known as the Microsoft.extension.caching.stack exchange Redis. Okay, so let's install that package in here to our service. Right click on dependencies, and I go to manage NuGet packages, and in here maybe what I'm going to do, I'm going to type in caching.stack exchange. Let's see if you're going to pop that one up. So stack exchange.redis. So we have Microsoft.extension.stack-exchange Redis. Yes. So make sure you install this package as well. This we're going to be using to manage our Redis as well. So let's see. Accept this. Good. And I believe you've done the installation nicely, isn't it? Okay, so now let's go to our controller. And now we're going to implement this. We're going to use this distributed cache. Now this actually enables you to, or helps you to interact with the cache, no matter how, or no matter who the cache provider is. It could be the cache memory, it could be the Redis, it also could be the SQL, and it could be the Redis, as I mentioned earlier on. But it's still, the implementation is still the same. Okay, so let's see how to go about this. To use the interface, we first have to register this. So let's come to this side. So I'm going to comment the netcode package, okay, because we're going to use it. We are using a distributed session, so I don't want to. Let me close this. Yes, so we have this, and definitely we're going to be closing all this as well. Let me comment this one. Also this. Actually, this is only the one, so I'm going to comment this. Okay, we come back to this later on, don't worry. Let's save this. Now from the program, we're going to be adding, so builder.services.add. Then here we're going to be using stack exchange Redis. Have you seen that? And here we need to specify some options. This options allows us to specify the configuration, that is the port. So in that, let's see how to go about that. First thing is option.configuration. You can see we have it in here. So option.configuration, and at this configuration, you can specify the 127.0.0.1, right? Or you can specify localhost, and at the port here it is, what is the port? 6379, isn't it? 6379, and that is the link, the connection link in here, right? That's the address. Okay, aside from that, we need to also specify the option. So option dot, maybe we can use the instance name, and that is my Redis, my app, my Redis. So my app. Good. Let me remove this. So what matters most is this one. So that's the most important thing. So now that we have this set, good. Let's go to our controller. From this, our controller in here, and now let's use this. So in order to do that, we have to introduce distributed cache. Now let's say this distributed cache. So let's grab the instance in here. That's an interface, and at this interface we can now have access to it. So let's say we are going to cache this. What we're going to do here is we're going to have, let's say this is order data is equal to await this dot, we have guest string, so we can use that. So we have guest string. So now with this guest string, we need to specify a key, right, and a cancellation token. So maybe we can just grab the key and the token from this angle and now paste it on in here. Good. This is very simple. Now when it comes to this section, we are going to set it. So in order to set it, we're also going to do the same thing here. And now we're going to do, say that await then distributed cache dot set, set async. You can now specify value as in byte. And this can now set the value as what? String. So before you set the value as string, you need to serialize it as we did in the wrapper. So here too, we have to specify the key, the value, and the cancellation token. So what is the key in here? That is a weather data. And what is the value in here? That is JSON serializer dot serialize this one, the data here, and we need a cancellation token. So cancellation token dot none, we can specify that, and now we are good to go. You see this? That's all we need to do. You return data. Now for cache clearing, what can we do? It is the same thing. I wait. So distributed cache dot, then remove async. Now let's pass in a token. So I'm going to copy this from here. Yes, I have a very simple one. Okay, when you copy and paste, it makes programming sweet. All right, now that we're almost done. We're going to run it. Now we make sure that our Redis is running. So when I check this, my engine is on it. Okay, I have a lot of fuel in it, so it is running. And also when you check the console from the Redis PowerShell, you see it is also running. It is in there. Now I'm going to run this from here, and now let's have a look. But before that, I think we're going to have an issue here because we haven't registered that. So let's remove this before it gives us an issue. Alright, so it is up and ready, up and running. Now let's see from in here we have our cache. Let's open our console so we can see the time being used. Now in here, let's open the weather forecast. We're going to make a first call. Now this is supposed to take 3 seconds. So it did not, it used the cache because I've already clicked on it before. So let's wait for 30 seconds to get elapsed so that we can have a new one. So this is also still using this one from the server. Let's wait. Now keep on clicking on this, clicking on this, clicking on this. Okay. Now let's see if I click on this to clear the server. Let's see what happens. So I'm going to clear the Redis. It has been cleared. Now let's see from here. Let me just close this. And now start from here again. Click on this because now it is getting it from the Redis server. That's our cache. It took 3 minutes. No, 3 seconds, 12 milliseconds. Now from this one, you can see 156 milliseconds. And if I clear this again, it's cleared. Since I make another call, it's going to delay this. So it tells you that our Redis is working. So this, if I open a new instance from another browser, I can still get access to that when the time is not due. So let's try this. Let me open one instance from another browser. I have Chrome in here. So I have an instance in here. Now let me just get this cleared. So I'm going to clear this. Okay. Now let me make sure I copy this. I go to the Opera. Then let me just run this to get the interface in here. Okay. I have this. Now let me execute this. So execute. I have this in here. It's taking 3 seconds. Now subsequent request is going to take 19 milliseconds. Now let's open the Opera. And in here, I'm going to right click on this, inspect element. Then let's check from the network tab. Within that second, there's a network tab. Let's see if the 30 seconds hasn't. Click on execute. Now try this. Execute. And I can see that it's using what? Only 149 milliseconds. Now if I click on this again, it's using 144 milliseconds. Now let's wait for 30 seconds to get elapsed. Now let's see if they're going to make another new request to the, you can see, now using 356 milliseconds. Try this out. Try this out. Try this out. So I find out that it does not automatically get removed. But if you click on this clear cache, as for that one, it will be removed. So let's see from the other app. If I clear cache from here, clear this cache. Now open the Opera, and as soon as I make another call, let's see the time that's going to take. Make another call in here. It's going to delay for about 30 seconds, and I'll make that call. No, 3 seconds. The reason is when we check our source code, we did not specify any option. We did not specify time, and I believe you saw that, right? I did not see it earlier. I just saw it. Okay, so let's have, this is options. We can specify is equal to new. We can have this distributed cache entry option, and now within that we can specify it. Maybe this is what we have: absolute expiration and now sliding. So let's use this one, and this is equal to time span dot from seconds. We want to specify the same 30 seconds. So when this elapses, whether this cache is being used frequently or it is rarely used, it's still going to get cleared off. Okay, so that's the reason why we're doing that. Okay, so now that you have this, we can now use this option in here from the set. Aside from this, let's see if I put comma in here, you can see we have option first. So let's put this option in here before that, and then trust me, there's no issue now. This is going to work 100%. Now let's wait and now check this out. Okay, so if I go for this one, you're going to make a request to this to record that time for my network. Try this out. Then it's taking our time, the normal time, 2.06. Subsequent one, 187 milliseconds. Now let's open this too. Now in here, clear this. Make another request in here saying it has been cached. It's going to take some milliseconds to get that, 65. Yes. But as soon as it gets up to 30 seconds, the cache gets cleared off from the server. Now let's wait and see. Check it out if you're going to have a new call for this. So even from the Opera to, let's see, from this, you want to get it, execute. Now you see it is now delaying for that 3 minutes, that's 3 seconds, right? Now when you go to our this side, execute, it has to get from the cache, and you can see quickly we got that. You see that it took just 77 milliseconds, and now that's an 80 milliseconds for that. Okay, now we can also clear the cache and now to make another call as well. So let's see from here to it's another 30 seconds elapses. Let's see if we're going to make another call to that. Yeah, you can see now it is making another call to this, and using that 3 seconds and 12 milliseconds. Good. So this is working. Okay, this is working. So that's a way to implement distributed cache and also the in-memory cache in here. Alright, so in a summary, we've seen that the in-memory cache here, it is used for a single server whereby data is cached in the server's memory for a subsequent response that comes in from the client. And now this improves the service response time, and also it sets the database free from processing or computing hard or tough queries. And also for distributed cache, it is used whereby you have to scale the application into more instances, whereby all of them are going to inherit from one server cache, and that is the Redis. And now we've seen how to run Redis in the Docker and how to connect it and implement your cache system in it. I hope you guys you love this, isn't it? Yes, if you do so, then don't forget to subscribe if you haven't done so, and click on that notification bell to receive update as soon as I upload new content. Also like this video if you learned something meaningful or informative for you. I do offer coaching or mentoring sessions to people who are interested in improving their skills. So if you are, just check the email description. Check my description. I have an email they can write to me through it. All right, take care, and see you again.